So in this problem, we're looking for the standard, what's the null space, but there might be some technical terms that you might have forgot. So null space, obviously, I think everybody remembers this. It's the solution to AX equals 0. And we set up the augmented matrix and row reduce and come up with the following: x1 is equal to minus x3. I think my subscript dropped off there. And x2 is minus x3 minus x4. Putting that into parametric form yields the combination of the two vectors minus 1, 1, 0, and 0, minus 1, 0, 1. So we've done this many times, and I feel like everybody in the class has done this perfectly as we've gone forward. Now, of course, we express the null space as the span of basis vectors, so those two vectors form the basis of the null space. From the number of basis vectors, we get the nullity, which is number 5. So since there was two vectors in the span, the nullity is 2. The next problem asks you to find the column space and the rank, and they ask you to find the column space in terms of basis vectors. So you have to do some work there. There are actually two ways to find the rank, and I'm going to show you both ways. The first method of finding rank, it's the number of basis vectors in the column space. So how do I find the column space? Well, I row reduce the original matrix, and then I identify which columns have pivots. And number 1 and 2 have pivots. Number 3 and 4 and 5 do not have pivots. They're in the wrong position. Because 1 and 2 have the pivots, basis vectors are going to be the first two columns of A. So the column space of A is equal to the span of the first two columns of A. The rank, by definition, is the number of basis vectors in the column space. So in this case, the rank is 2. Another way you can get the rank, and I've used this before in a proof recently in the last lecture, is to use the rank nullity theorem that says the nullity plus the rank is equal to the dimension of the domain. Well, what is the domain? The domain is actually the x vectors. It's the space that the x vectors come out of that makes your multiplication work out. And you've realized here that you need 4 components in the vector x in order to make the matrix multiplication AX work out. So the dimension of the domain is 4 because I need 4 components here. It's really the answer to the question, what vectors can be plugged in for x? The domain itself, which is one of your questions, is R4 because I'm working with 4 component vectors. So I know the nullity, it's 2, I already calculated that. I know the dimension of the domain, it's 4, and by using simple high school algebra, I can get the rank to be 2.